Hello, everyone. Welcome. Thank you so much for joining us today. Before we officially get started, we'll do some quick introductions here, and then we'll pass it over to Dakota to get us started. My name is Kayla. I'm here representing Acelab. We have Bo here as well from Acelab, as well as Dakota here from Kingspan, who will be walking us through the presentation. So before I pass it over to him, I'm going to go ahead and take you over to Acelab. So in just a moment, you should be able to see my screen. And here we are in Acelab. So if you're not already familiar, a great place to start in Acelab when you're looking to do some research is this search bar at the top of your page. So in this case, you can toggle over to manufacturers. You can also check out our new AI search right here. It's a great new tool as well. So here on Kingspan's page, you'll find some really great information to explore through. We've got some value propositions as well as their products here for you to explore. So you can click into any one of these pages. You can click right here and actually save it to your firm library as well for future reference. So when you have a moment, check out their page, kind of dig in a little deeper here. I will drop a link to this page in the chat in just a moment. All right, a few other things to make note of today. This is an AIA-approved presentation. We already collected your numbers upon registration, so you're already most likely good to go there. However, if you're worried we didn't get your AIA number, I will also be dropping a form in the chat for you to fill out, and that way we can ensure you get credit for today's session. We will also be doing Q&A at the end of the presentation today. We'll get to as many questions as we can. So if at any point you have a question, you can click that button for the Q&A at the bottom of your screen, drop your questions in there, and then if we don't get to all the questions today, we'll be following up over email as well. We will also be doing a webinar poll. You're going to see that pop up on your screen about 3/4 of the way through the presentation. That is an optional poll. If you're not interested in getting any kind of follow-up information after the webinar today, you can click the X, it'll go away. However, if you are looking at and getting connected with Dakota and his team, fill out that poll with any specific questions or projects that you may have. We will connect you via an Acelab conversation. So keep an eye on your inbox for a notification for that conversation after the webinar. You can respond directly to the notification email, or you can log into your Acelab account and respond to any conversations there. It's a great way to discuss specific projects or get any further questions answered directly from the Kingspan team. Lastly, we will also be doing a post-webinar survey. So any feedback is greatly appreciated. You can leave that there at the very end. So with that being said, Dakota, I will go ahead and pass it over to you to get us started.
Thank you so much, Kayla, and great introduction. Thank you so much, everyone, for having me. Thank you, Ace Labs, for having me. Kayla, just to confirm, you can see my screen still?
Yes.
Okay, fantastic. Well, thank you again, everybody, for having me. My name is Dakota Jones. I'm the Business Development Manager for Kingspan Insulated Metal Panels here in the Mid-Atlantic. I'm based in Philadelphia, so if you need anything close by, please feel free to reach out to me. I'm happy to talk about the Eagles or get you guys any samples or anything that you guys need. So, a little bit about myself before we get going. Um, Today we're going to be talking a lot of building science. It's a passion of mine. We are here to talk about insulated metal panels as well as their use as rain screens as well. We will get there. Um, I come from a background in architecture. I have a master's degree in architectural building sciences. I'm originally from the University of Idaho, but my fascination with sustainability as well as envelope design really led me to join Kingspan here. So my background is in architecture, but I'm pretty new to sales. So if you guys have questions, please feel free to send me. I try to be as knowledgeable as I can with these things. So that being said, we're here to talk about Kingspan high performance rain screens designed with insulated metal panels. Again, buckle up. It's a very building science heavy presentation. But before we get into that, let's get a little bit into Kingspan and a little bit more about what you're going to learn when you go onto our webpage today. Uh, Kingspan's an old company. It's been around for a very long time. We actually have rather humble roots, started in Northern Ireland. Or actually, I guess just the regular country of Ireland, King's Court to be exact. It's a family-owned company. It started behind a family-owned pub in Kings Court, and to this day, it's still kind of just the pub in Kings Court in Kingspan. So, despite that, we've managed to grow though to be the number one IMP specified IMP manufacturer in the world. We also occupy over 80 different countries now. We have 212 manufacturing plants. We just added a new one domestically in Illinois, making mineral fiber panels themselves. We are a multi-billion dollar company. We'll talk about that in just a minute. And we also have a whopping 22,000 employees worldwide, which is significant. So, keeping that in mind, the reason Kingspan's been so successful over the years is because of our diversity. Kingspan IMPs is what we're going to be focusing on today. It is kind of our flagship where our bread is buttered for sure. But even if you haven't heard about Kingspan IMPs, you might have heard of our other companies. We have a whole insulation department, and you might not know that we do hemp fiber insulation, we do wood fiber insulation, we do wood insulated walls, insulated roofs, we do photovoltaics, we do semi-transparent panels and skylights and all different kinds of stuff. All these companies with the single-minded focus of giving you guys, the architects, the designers, the tools you need to make really interesting net zero buildings. And this is going to be kind of a reoccurring theme. So keep that in mind that that is our mission, and we've been very successful in that. Kingspan's been leading the industry for about 60 years now, not only in innovation, but also in sustainability. And we credit a lot of our success to our commitment to sustainability. About 15 years ago, I would say, we started the Planet Passionate initiative, and this was impressive enough to pull me out of architecture. But basically, this was before sustainability was like really cool to be talking about. But Kingspan, as the manufacturer, saw the writing on the wall, which was later justified by organizations like the USGBC, that the built environment had a tremendous impact on the environment overall. And as a manufacturer, we saw that we were a big contributor of that. And so, keeping that in mind, we decided to change some of our manufacturing process to have less of an impact as far as environmental concerns are concerned. So, like I said, USGBC later validated these kind of hesitations we had about our impact overall in the industry. This is based on 2020 numbers. If you guys aren't familiar with these, we'll go through these very quickly. But back in 2020, they found that about 33% of all global energy is consumed by the built environment. It's a very, very significant amount of energy that we're using to maintain, operate, and expand what we currently have. Now, despite that number being very high, we also are a contributor of greenhouse gas emissions. About 40% of all greenhouse gas emissions are directly produced by us, the manufacturers, the built environment, unfortunately. And despite these numbers being so high, only about 3% of our current building stock is considered efficient by today's standard. A whopping 97% inefficient by today's standards globally. The reason for this, we hear a lot in architecture firms. I know I heard it a lot when I was practicing architecture, is that we have to build up to code, right? Got to meet code, got to meet code. And that's very important to meet IBC, IECC, stuff like that. But when we keep that in mind, what we're actually doing is meeting kind of the bare legal minimum as far as energy efficiency and performance is concerned. And so, if we want to have a tangible effect on decreasing this number, increasing the efficiency of our building, we need to think about a few strategies we'll talk about here in just a moment. The last kind of twist of the knife, though, I do want to highlight is embodied carbon in the built environment. A whopping 11% of embodied carbon on the planet is sitting in the buildings that we currently occupy. Um, this is why adaptive reuse is so important. And, unfortunately, with a lot of this carbon sitting in the bricks and the glass of these buildings that aren't really performing for us, at the end of their life cycle, they're not even recycled, unfortunately. So, with only about 9% of building materials being recycled nowadays, it's kind of this use, make, waste mentality that we really need to get away from as an industry overall. And we'll talk about how Kingspan is hoping to use that in the future. So, the one thing that we are for sure about is that we want to have a tremendous impact on lowering these numbers, but unfortunately, because of humanity and the way we are and our expansion and all that stuff, these numbers are projected to increase a little bit. The USGBC estimates that we need to about 2x our global floor area of the built environment. It's the equivalent of adding the entire city of Paris to the planet every week for the next 25 years. It's about 1,300 Parises. It's a lot of carbon and a lot of energy that's going to be required to do that. The USGBC again estimates back in 2020 that this would require a 50% increase in our already tremendous energy demand. I think honestly, this was before they knew about the AI race. As a guy who does a lot of work with like data centers and mission critical work, the amount of wattage they're talking about needing just to maintain what they already have, I actually think this might be a gross underestimation. So these numbers are already pretty staggering, and they're projected to increase, unfortunately. So again, Kingspan saw this and understood that we could make kind of a northern star a sustainability Northern Star, if you will, that we can measure our own success on. And so these goals are kind of listed out here, how we were going to measure our success. The first is energy, carbon, circularity, and water. It's really that easy. Specifically with energy and carbon, we talked a little bit about acquisitions, aligning ourselves with other companies that, again, give you guys the tools you need to make net zero buildings. How do we do that? Well, we want to make sure we maintain as close to a net zero energy status as possible, meaning we're not taking more than we're producing. A lot of this is doing things that just make sense, adding photovoltaics on these massive 300,000 square foot manufacturing plants that we have, as well as reducing emissions where it just makes sense, combustion engines and things like that. And Kingspan takes that very seriously. Forklifts on the manufacturing floor, electrified. The company client vehicle that I'll come see you guys all after this presentation, and company supplied Tesla Model 3 reusing renewable energy. So they really take this stuff seriously. It's pretty insane. But circularity is where we really shine, especially as a manufacturer that is responsible for producing a lot of waste, you know, traditionally. Kingspan's committed to being a zero company waste to landfill by 2030. Ambitious number that I'm sure we'll hit because we've managed to reduce it significantly. And we actually even started our own take back program. Well, I'm getting ahead of myself though, so we'll get back to that. Circularity is essentially how much waste we're producing and how much we're actually taking waste out of landfills and then reintroducing it into our manufacturing process. The insulation of our panels that we're going to be talking about today, you'll notice it's this distinctly gray color. And the reason for that is because it's a proprietary hybrid blend of polyisocyanurate. And the reason it's gray is because it's 11% recycled post-consumer plastic, meaning that we're actually taking plastic out of the environment and putting it in our building products. At the end of the building's life, when these buildings are being dismantled and there's no longer a need for IMPs, we actually have a take-back program where we can take the panels back, mulch the insulation on the inside, put it in concrete as aggregate to make it lighter weight, heavier insulation value, and then the steel is recycled entirely as well, thus eliminating even more potential carbon from getting in. So this is the tools that we use in order to offer you guys things like environmental product declarations, as well as life cycle assessments, which you'll need if you're pursuing well or lead credits, things like that. And so again, it's in that effort to give you guys the tools you need to make. I see where I'm going with this. The final thing we'll talk about, though, is surrounding water. And depending on where you're located, out here in the West, in the domestic United States, is not something we talk about too often, unless, of course, California is on fire for like the 17th time that year. The Colorado River has even made it to the ocean. This is a growing issue. And so Kingspan, again, as a very large manufacturer, wants to make sure that we're doing our best to harvest our own water to use in our manufacturing process so that we're not depleting local aquifers. So keeping these kind of northern stars in mind, we've managed to have a tremendous impact. And this is just 2020 numbers, so this is a little out of date even, but still pretty impressive. I'll share with you guys here. Starting on the top left, we managed to conserve just by modifying some of our practices, blowing agents, relying on more photovoltaics and renewable energy resources, 9 billion lumens of energy conserved from our baseline. It's the equivalent of what a million US homes use over the course of a year. It's a lot of energy that we've saved. Additionally, 164 million tons of carbon from entering the atmosphere. That's a big one. It's what a major airline uses over the course of 15 years. Significant. And then, of course, kind of laughably, we originally had a goal of harvesting 100 million liters of water. We grossly underestimated that. 34 billion liters of water is what we actually managed to harvest. It's the equivalent of what you can use to fill over 400 million bathtubs. So, quite a bit. Then, of course, we talked about upcycling plastic. We're to the point now, honestly, this 573 million plastic bottles we upcycled in that first year is kind of old news, to be honest. Now we're doing a billion every single year. We're to the point where we need it for our formulation. We actually have every incentive to continue down that path to, again, lower that embodied carbon that's going onto your guys' building. So, with that being said, that's a little bit about Kingspan, and you're probably wondering, like, wow, right, guys, coming out swinging with the sustainability stuff. Oh, geez, I wasn't expecting that. Just know that this is very, very in line with what Kingspan knows and believes, and a lot of people don't necessarily care about what you know until they know about how much you care. And Kingspan really, really cares about the environment. One is we've had a lot of success in pursuing sustainable design, and it's been very successful for us. We work with very big companies, but also I've mentioned a few times now that we're a European-based company. And that's a very important part, is that that means that we are one, adhered to the Paris Climate Accords. Two, As a European traded company, we have to show that we are setting sustainability goals and then showing meaningful steps that we're actually taking to achieve those. So just know everything we just talked about for the past 5 minutes, if you don't care about any of it, it's still happening for free in the background. Don't even worry about it. This is just how we do business, right? We're not greenwashing our products. We're not charging you some kind of green premium for any of this stuff. We're still very price competitive. We have the highest R value on the market for insulated metal panels, R8 per inch, using our proprietary blends. So just know this is what we do. This is how we found success, and this is how we're going to continue moving forward. So thank you for locking in with me there during the Kingspan kind of dog and pony show. But that is what you'll come to learn as you explore our website on Acelabs. We are going to transition into the AIA portion of the presentation, less proprietary talk, but more building science, which is my forte. Just keep this question in your mind before we get going, though. We're going to be talking a lot about the complexities of building envelopes and how we can make them simpler by using single component systems like an IMP mounted directly onto studs. It's your entire wall system in one, right? What recent envelope challenges have you guys experienced? Whether that's speed of install, performance, innovation, things like that. These are all questions that I hope are being raised to you guys as we continue through this presentation and start thinking about where IMPs could be a good fit for your projects. Now, as Bo mentioned, as Kayla mentioned, rather, excuse me, you guys will be receiving credit for this. This particular presentation, you will receive a CEU as well as the HSW credit. So good for you for double dipping on that one, but expect those certifications relatively soon. But here are our learning objectives. If I do my job correctly, we should be able walking out of this presentation knowing how to, one, design an effective building envelope, the foundation of what we're going to build our whole conversation on. We're going to be talking about the challenges of multi-component built-up walls. This is the segregated kind of wall sandwich where each piece is its own individual part, sheeting, air barrier, insulation, all this stuff making up a wall sandwich, right? Can move around a lot depending on a lot of different factors. We'll get into it. We'll then compare and contrast that, how we can get higher performance out of a single component backup wall systems. Spoilers, is going to be about IMPs. And then we are going to be talking, when everyone's tired of hearing me talk, showing some case studies, as well as showing the design flexibility of how you can use IMPs, not only as an exposed system, but also as a backup wall for a rain screen in case you don't want to pursue a metal facade. So we'll get into that. Objective number one. How do we design an effective building envelope? Well, thank you so much for asking. Let's get into it. Now, we talked about that big scary 97% ineffective number. Now, if we want to have any effect on that, because again, the IBC pretty reliably updates and it never gets any more lenient on its energy performance value. So we know it's going to increase. And if we want to have an effect on that number, we need to start thinking about these strategies to go from baseline efficient walls to highly efficient walls. How are these going to last the test of time 50, 100 years down the road? The first one, very self-explanatory, super insulation. It's a must, right? This is our main barrier from thermal loads entering into our building. Going above and beyond that minimum required R value is going to be worth its weight in gold in the future. But then again, we don't want to make something crazy like an R80 wall and then have a bunch of cracks and seams and poorly jointed details in our windows leading to air infiltration, especially unintended air infiltration, because again, that's energy going in and out of our envelope, leading to inefficiencies. Cold surfaces can start to condensate. That can lead to health and safety issues as mold begins to grow, things like that. So airtightness almost just as important as insulation. Then finally, we don't want to go through the trouble of making a super insulated, airtight box and then ram a bunch of structural members out of it, in and out of it willy-nilly, right? That's still an inefficiency. That thermal bridging is going to allow energy, coolth, and warmth to bypass those materials, depending on how conductive they are, and again, lead to inefficiencies over time. So reducing that where possible, we'll talk about that when we get to Zegerts, but it is also a must. However, you guys are all architects, we're all designers. Hopefully, most of us know how to design walls nowadays. As long as we adhere to the basic construction methods of employing a strategy to control rain from entering our building, air from entering our building, again, unconsequentially, and then vapor and thermal loads from entering our building. As long as we have defenses against those, we should have a wall that's going to last the test of time. Now, in Dr. Joseph Stiebrick, a very famous building scientist paper, The Perfect Wall, he has this rather cheeky quote that kind of argues for the holistic nature of high efficiency walls. Again, top to bottom, kind of macro to micro scale. If you can't keep the rain out, don't waste your time with the air. If you can't keep the air out, don't waste your time with the vapor. Again, making the holistic argument of like, if we have a big hole in our roof via chimney or something like that, do we really need to worry about an air barrier? Or is it just going to come in through the chimney? Just going to come in through the big hole in our roof? Additionally, on a more micro scale, that's pretty obvious, the chimney, but on a more micro scale, these windows, these historically preserved wooden windows, I'm looking to the ones to my right here in my home that rattle all the time, right? If we have a bunch of air infiltration, do we really need to worry about a vapor barrier? We should, for sure, but also it's just going to come in through the, shortest resistance area, which is going to be those leaky, creaky windows. So again, holistic. This is not just the opaque surfaces, it's the transparent surfaces and the joinery specifically. Now, the reason we want to be kind of belt and suspenders with this approach, right, is because of this sneaky way of water getting into our building. Hydrothermal loads. I know this seems like a misprint or a weird word, I promise, even though it sounds kind of silly, looks kind of silly, it's a real word. It's a building science word. It's the intrinsic movement of heat, air, and moisture through your building envelope. And if we've ever had a can of Coke on a hot day, we know that that condensation can occur when the humidity in the air touches a cold surface. It condensates, and if it has nowhere else to go, it's going to sit there. And so, if we remember in our building science days, we know that even like a 1 inch cut in a vapor barrier can lead to like potentially cups of water sitting in your wall cavity over the course of time, which can lead to best case scenario, grandma's basement smell, worst case scenario, structural damage, mold affecting the health and wellness of our occupants. So, again, really want to double down on this efficiency. Hydrothermal loads, bad, bad, bad. How we've learned to kind of adapt our walls to be more performative, last the test of time, is kind of illustrated here, starting at the top of what we used to do quite a bit, mass storage walls, which you guys might recognize or may not recognize as a thermal mass wall. This is local materials, often rubble, stone, concrete masonry, things like that, composite, concrete, that kind of stuff. And this did everything that a thermal mass is supposed to do, which is doing a fantastic job of absorbing, storing, and then redistributing not only heat, which is what we expect of a thermal mass for sure, but also water because of the porous nature of those materials. It soaks all that stuff in and then it redistributes it on both sides, which is unfortunate. And then that's how you get your grandma's basement smell. So we've moved away from that as our only strategy because, again, it's not holistic, it's not blocking water or anything like that toward the barrier wall system, right? And this is a more robust material, less permeable, something like glazing, something like steel. No water's getting in through there. But unfortunately, you can't cover an entire skyscraper with one sheet of glass. So we have to break it up. These are often 4x8 materials, right? With the joints and the seams ultimately being the point of failure, right? And so again, good strategy. We still make windows, buildings with windows every day. I'm not saying we don't need to use either of these strategies. We can just do it better. So what we've done is kind of taken the idea of a wall that can breathe via this mass storage wall, combined it with this really rigid barrier wall system, not going to let anything through, and we kind of hybridized the two toward a drained assembly system. And what this is an engineer's dream because, again, redundancy, right? So what we have here is a backup wall, this barrier wall system with an air gap in front of it. We'll talk about why that's important in just a moment. And this exterior shield, right? And so what we have is a wall with a shield blocking from wind-driven damage, as well as blocking out like 98% of that rain from getting into this system. And then this air cavity, which is integral to rain screens, allows that last 2% of water that gets through that envelope system to condensate on this backup wall and then through gravity be carried down to a weep hole at the base of that wall. This is again a redundant system. It's shielded. It's going to last the test of time. And this is what Dr. Joseph Stiebrick in his paper, The Perfect Wall, identifies as the perfect wall. Surprise, surprise. Now, that rain screen can be virtually whatever we want. That's more a conversation about fire code. We want to make sure we're adhering to that while still maintaining our design intent. But that air gap is very important for all the reasons we just talked about. But that backup wall, let's talk about that. That's where the magic happens, right? This is where our strategies are employed to make the perfect wall. All of our thermal controls, our air controls, our vapor and water controls, all of those are going to be back here sitting protected from those exterior elements. And this is why this is a wall that's going to last the test of time and has been proven to do so, and why we kind of use it all the time today. So, rain screens are fantastic. I'm not arguing against them. I am a big advocate for it. I think rain screens are great. There's a lot of pros to them. Let's talk about it, right? The effective moisture management of that system, it's immense. It's beautifully thought out for all the reasons we just talked about. It's versatile in its aesthetics. Depending on what your design intent is, that exterior rain screen can be whatever you want. It's also very common nowadays. A lot of people know how to detail it. A good amount of AIA presentations are talking about rain screens and how to make them, right? But they're also uh, some pretty significant cons. And a lot of this is due to the complexity of, again, the segregated nature of those materials working in junction to form as one wall, right? And so this is kind of our wall sandwich that we need to know quite a bit about if we want it to perform correctly. So complex assemblies, big pullback. We'll talk about why that's so bad in just a moment. Higher maintenance cost, right? This is again different pieces, different materials making up a built up wall. This is multiple trades doing multiple trips around your building, longer construction time, more insurance, more people on the job site, right? And then, of course, even though all those things are going very well, there's energy efficiency limitations. And we'll talk about this when we start getting into sections of multi component systems in a rain screen. But these are, again, 4x8 sheets. And whenever a system does fail that is supposed to be watertight, it's normally at the joints. So we'll talk about why that's so important in just a moment. Now, to highlight the kind of complexities, the challenges of multi-component systems, and why we're advocating today for a more streamlined single component backup wall system for your rain screens, even if you don't want a metal facade, we're going to illustrate the kind of typical steps you would need to take in order to actually produce a high-performing wall. And then we'll contrast that with the multi-component system. So, challenges of multi-component backup wall assemblies. Starting off with step one, figuring out where you are. How is this thing supposed to form, right? ASHRAE 90.1, a map that I hope you guys are familiar with, but if you're not, Google it. Very important, right? I envy you if you don't know, but this is really important science stuff. So, this is going to inform a lot of how your wall needs to perform. It's going to tell you whether or not you're in a dry environment, a moist environment. And this is going to inform how thick, how thin, the kind of area of where your wall needs to operate where it's being located. You can imagine a wall in my hometown of, Boise, Idaho down here is not going to look the same as, something on the tip of Florida. It just isn't. So keeping that in mind is going to inform quite a bit. It's a vital step one. Step two, though, is going to our trusted manufacturers, going on to Acelab and seeing what we can do, right? And this is where complication can start rearing its ugly head, unfortunately. Just with air barriers, vapor barriers, things like that. Weather resistive barriers. The reason I'm throwing so many acronyms and words at you is because these can serve as sometimes double duty, depending on their permeability, how much water can get in and out of that system, not to mention the amount of forms they come in. I mean, they can be wraps, they can be fluids, they can be sheathing. Got to know how to use them, got to know which one's doing what, because some are vapor barriers, some are water barriers, some are both. And, again, once you get it figured out, you're probably fine. But again, it's a step of complexity that we argue is ultimately unnecessary. But to make matters even more complicated with just that first step, these are broken down into classifications of permeability, which is what I mentioned. For those of us who don't know what a perm is, essentially it's a drop of water that can make it through like a square foot of a medium over the course of an hour at like nothing pressure differential. So you can imagine something like steel would be considered impermeable, class one, right? 0 to zero point 0.1 drops of water getting through that bad boy. But class three, 1 to 10 drops per square foot per hour. That's a pretty vapor open system. Like we got to think about how we're going to allow that water in and how we're going to allow that water out. Again, a step that we really need to know if we're going to do this correctly. But let's say everything goes well. We make our selections, we know what we're doing. Hopefully, we've gone above and beyond on our required minimum R values for our insulation. How do we connect this thing, right? Well, that's when we start figuring out our diagrams. And this is where thermal bridging gets to come into the conversation, specifically with Z-girts, right? We can look at this typical wall section of a multi-component system. We have our backup wall doing great, supporting that rain screen. We got our air gap, everything's rocking and rolling. But we have this very important insulation layer, which is going to protect this backside from getting cold. If this backside gets cold, condensation can occur on this side and this side. You can see here, as far as paths of least resistance, cold is going to come in through here, find this conductive material, this metal Ziegert, and then collect back here, making this back surface cold. And then, of course, condensation can occur it's an unfortunate scenario that even if we do everything perfectly, ultimately something like this happens where we have this very obvious short circuit occurring. And they make fiberglass secrets. I encourage you to look into them. They're very nice, though some people might not be able to justify the expense. But this is what happens in the best cases of scenarios. And to illustrate that point further, this is the best case scenario. Look at this. This is a beautiful assembly of a backup wall, right? Oh, we got all of our tape. Everything's all tightened up. Oh, my goodness, my timer's going off. Pardon me. But if we look at it pretty closely, it's penetrated thousands and thousands of times. And somebody in the chat can certainly correct me, but I don't think the GC's coming back to the job site after the fact to kiss every screw on the head and tuck it in at night with non-skidding butyl and make sure every seam is taped perfectly and there's no air bubbles and all this stuff is done perfectly. Subcontractors miss studs, right? Things happen out in the field. We're human after all. And so what we're relying is on near perfect installation in order for this to actually affect and have a really long effective timeline as far as this wall is made. And so what we have is a system that is the perfect wall for all the reasons we just talked about, but unfortunately is inherently imperfect due to its complexity. And to finally highlight the kind of final point I'll make about this is, of course, the maintenance cost, the lead times, all this stuff, right? Here on the top, we'll compare two ACM applications in this case, aluminum composite material for those who don't know. Here, again, built up wall system, segregated, multiple pieces and different pieces. This is going to take on average 3 to 4 trades. 3 to 4 trips around the building, again, longer construction time. But then what happens if there's a situation 2 years down the road? Mr. Owner calls you up and says, "Hey, Mrs. Architect, uh, there's a leak in my window. It's raining in my building. What's going on?" Right? All of a sudden, you go to the window guy. The window guy's pointing the finger at the ACM guy. The ACM guy's pointing the finger at the plumber for some reason. Everyone ultimately points the finger back at who? Back at the architect, right? It's a situation just like this. It's a who's who of who screwed up. So many different directions you could point the finger, but compare that, sorry, compare that to a single component system, an IMP, an insulated metal panel down here. Truly one throat to choke. I mean, look at this. Studs, IMPs, ACM. Taking the complexity out of it. This can work in every single climate zone. It also installs 50% quicker than multi-component systems, meaning that you're heating your building sooner. Your interiors are getting started sooner. And then, of course, if there is an issue, it's either you or it's me. There's not really anyone else in the ring to blame. This brings us into finally talking exclusively about IMPs, insulated metal panels, high performance backup wall solutions. How do we make the perfect wall more perfect? Of course, we make it less complex. So, big claim, right? IMPs can be your entire wall in one. How does that happen? Well, let's look into it a little bit. Here's as complex as IMPs get, right? Right at the joinery. And these panels, keep in mind, are like 42 inches by like 53 feet, meaning it is 53 feet of steel, insulation steel, a barrier wall system. Nothing's getting through that bad boy for a good chunk of square footage. When we get to the joints, what we see here is redundancy. Again, engineers' dreams. We have pressure equalization happening between these two as the building is pressurized from the inside and the outside. That's where our air sealant comes in. These are double gasketed joints right here where the two IMPs actually connect together. And these things go together just like Lego kits. They snap on top of one another, as illustrated right here. Now, I already mentioned steel. It's not aluminum, it is steel on this exterior face. This is also steel. And because of that, we can essentially riddle this exterior face with all kinds of holes, and it would never affect the weather tightness because there's steel to rely on back here. The insulation itself, so high density, polyisocyanurate, that it doesn't intrinsically suck water up. We often actually leave it exposed and there's no issue with it like actually getting soaked up or anything like that. So that's not an issue. The steel itself is galvanized, meaning that fasteners that do pass through it and make a nice snug connection, self-sealing, right? And so what we have is a system that blocks air infiltration and vapor by association. Thermal insulation blocks our thermal loads from getting in there. And then, of course, water infiltration because it's steel, just runs right off the side, right? So what we have is a system that can work in every single climate zone, all in one, mounted directly to studs. If we look at the thermal performance as far as what we can expect from our energy or from our envelope, excuse me, and compare it to a multi-component system, right? Again, we have our trusty, in this case, single skin multi-component system. This is where those darn Z-girts get to rear their ugly heads again, right? very obvious short circuit through that envelope. You can see the temperature differential throughout there. It's pretty stark. It penetrates very, very deeply. When even at the most complex points that Kings or not Kingspan IMPs get, which is at the joint, we have much more consistent thermal performance, meaning that this backup wall is more likely to stay the temperature that it needs to so that condensation doesn't occur and we don't have issues later on down the line. We'll talk briefly about the insulation itself. As I've mentioned, our brand, it's a proprietary blend. I can't say its name. We'll refer to it as ultra high performance PIR. That's the gray stuff I mentioned with the R8 per inch value. It's polyisocyanurate. It's hybridized because it's formulated in-house. But standard PIR, which is shorthand for polyisocyanurate, is kind of an industry standard now. And the reason for that is because our value for sure, on average, it's like 7.2 per inch, which is great. But mainly it's for fire performance. Plastic insulations have gotten a bad rap for, a little bit before us, but we used to, as an industry, use polyurethane insulation. And this stuff, if those of you guys know, horrible as far as fire performance is concerned. It smoked quite a bit. It dripped, it bubbled, it just wasn't safe to be around. And its R value was like 5.2. It wasn't even worth keeping around. But now, as an industry, no matter who you end up choosing for your IMP, polyisocyanurate is going to be the standard. That's like 7.2 on average. As I mentioned, most of the times it's going to be FM approved. And again, its fire performance is significantly better. If you blow a torch at this thing, it's going to char up. Virtually no smoke, much, much safer to be around. And that's why, as an industry, we've moved away from polyurethane. But if fire performance is on the brain, right? You're doing something crazy in New York. It's a zero lot line condition where you have to find a way to attach it on the inside. That's not a big deal. Because IMPs can be stacked on the top of each other and be attached from the inside, we can do something like this. Swap out the cores for our handy dandy mineral fiber, right? You can see here that we take a little bit of a hit to our R value, but we can get you a 3-hour wall out of this stuff. This is mineral fiber, rock wool, basically. Non-combustible, it's good to go. And so we can make thicker panels, attach it down horizontally and install it from the inside. And it's the perfect application for that type of a thing. Again, you do take a hit to your R value compared to the baseline of the high performance PIR, but very good alternative if that's your priority. Just know that that's an option for you. Now, hopefully this should answer any lingering questions of like, how does this thing go together? Well, let's look at this. So this is again, as it complex as it gets, is where two IMPs meet butt to butt after the 53 feet of length, right? What we have is a double stud condition with a mending plate to give us a nice flat surface to essentially glue our IMP on using something called a non-skinning butyl. It's essentially a silicone-like material that never quite gets dry and allows the building to move a little bit while keeping our air and moisture sealant nice and tight. Now, we saw the two lines of that sealant go on, that butyl, and then the IMP put on top of that structure. This is attached directly onto the studs. It's then fastened via a clip onto there, and then you just saw two lines of that non-skidding butyl going over that back gasket. The reason for that is to keep the system from being compromised laterally as far as water infiltration. Very important step. We call that a marriage bead. It'll be shown just in a second again as the next IMP goes on into its right. IMP goes on there, it's glued, double fastened, saw that marriage bead again, that next IMP goes on top. And then, of course, we have this pressure fitted gasket, which is going to keep water infiltration from occurring, but some of the eagle-eyed among you might realize, hey, that's a very obvious thermal short. What are you talking about? It's just rubber over studs. Totally get it. Yeah. What's not shown in the video, to my utter dismay, is at the very least we would recommend you put some mineral fiber behind this bad boy. But since I'm the high efficiency guy, I would recommend something more akin to this. This is a block spline detail. Essentially what it is, smaller IMP attached to that double stud system before any of the stuff goes on there, and then we notch out those IMPs for you, and then we have nice consistent thermal performance. Insulation on insulation contact, much, much more reliable than something like this. This will perform, it's just going to allow that to get cold, unfortunately. There's just no way around it. So keep that in mind. If you guys have questions about that install video, now would be the time to type them and we can get to them at the Q&A at the end there. So this is the time where we get to wake everybody up as far as some case studies and learning more about the design flexibility of IMPs. Now, we know it can be an exposed system, and we'll continue to talk about that, but it can also be a rain screen. Now, to illustrate that, again, we'll look at this section detail here, right? What we have is a IMP attached to our studs like it should be, but we can take advantage of the complexity of that joint and suspend a little hat channel on there, right? And so what we have is backup wall, hat channel, air gap, and then we can supply whatever that exterior rain screen is. This is the perfect wall. This is the rain screen we were just talking about, but way less complex. And so what the other thing I want to highlight here too is obviously these fasteners are going through that IMP back to the structure, meaning that the IMP is actually not supporting the facade load, the structure is, but as long as you're keeping that in mind and adhering to fire code, you can make this as heavy as you want there as long as the structure is there to support it. We, in this illustration, have it installed IMPs horizontally. They can be installed vertically as well. And then, of course, to get that airflow, because there would be an obvious guttering happening here, we have this perpendicular head channel go there. I get that question quite often. So just know in horizontal applications, you will have to run it both ways, unless you, of course, you're doing something deeply corrugated like that. But anyway, I'm getting ahead of myself. If you get confused about that, let me know. So we can take advantage of this rain screen technology, this integrated hat channel, and we can suspend non-metal facades if we want to, or different types of metal facades that IMPs just can't do due to the kind of nature of our jointed system. So we'll go over a few examples of what we're seeing growing in the market. This is kind of based more toward the Mid-Atlantic, just because that's where I'm based. This is where I do those presentations, but it should be applicable to everybody here in the States and abroad. Plate. It's a really, really good way of getting metal on a building, and the reason for that is because it's truly as non-combustible as it gets. It's straight up metal. It's not a sandwich panel like ACM or anything like that, but it's thicker. It's a thicker sheet of metal. And the reason you want that thicker sheet of metal, mostly in flat applications, is because it prevents a phenomenon called oil canning, where essentially that metal heats up or cools down a lot, and then it gets kind of wavy. It gets kind of ugly on a building facade. So we don't like that. Plate does a really good job of helping prevent that. It can't obviously prevent that because hot days do occur, but it does a good job of keeping rigid for longer spans. IMPs also do a good job of doing this. You've seen all the sections now where the IMPs adhere directly onto that insulation on the inside, and then it's a sandwich panel. Because this is a 3 or 4 inch panel, typically, can stay much rigid for longer spans, typically about 20 feet before we need to start having a conversation about oil canning. So just know IMPs can also do this as well. But plate, great way to get metal on a building, especially if you're pursuing a rain screen. ACM, MCM, aluminum composite material, metal composite material. Again, for those novices out there who are like, oh, what is this? I guarantee you know what this is. It's on every car dealership you've ever driven by in your whole life. It's a very popular product. The reason for that is because it can do everything IMPs can't do, because it doesn't have to rely on that really complex joinery system. And so you could make stars out of this if you really want to. You can paint it all different kinds of colors, do all kinds of complex geometries, line up with window mullions, do up tons of stuff pretty cheaply. That's why it's so popular. This is a sandwich panel. There are cores, often fire rated, for taller assemblies, things like that. But this is very common nowadays, not going anywhere. And again, another great way of getting metal on a building. To illustrate the comparison between something that you can achieve with an ACM MCM versus like an exposed IMP, I'm just going to do a quick comparison to kind of get your mind thinking more about what IMPs can do. What I have here is two unlabeled images. This is kind of a little guessing game, right? Again, to kind of connect it, the learning here we're doing with something real world. One of these buildings is an IMP building. The other one is a built-up rain screen using ACM. Now, normally I would have you guys guess this aloud, but since we're all virtual, we'll hang on for that. But in your head, guess which one is which, and I'll review it in 3, 2, 1. There you go. So IMPs are on the left, right? We can still do fun colors. We can still do fun geometries. It's not a big deal. Another thing to mention, again, for those eagle eyes out there, Miami, right? This is the David Beckham Miami Soccer Stadium. These panels are very durable. They're Miami-Dade certified, meaning that this can be erected in Florida, no problems. Again, all different types of climate zones this thing is commonly assigned to, and we can still do cool colors, shapes, all this stuff. It's all the metal is coated by a small company you guys might have heard of, Sherwin-Williams. It's a joke. Everyone's heard Sherwin-Williams, but we can do a lot of fun high design stuff, just like ACM and MCM can. We can still have fun that way too. The other fun thing we can do. Single skin profile, the kind of last flavor of metal we'll talk about getting on a building, right? Corrugated looks. This is coming back in a big way as people are adopting more of an industrial look in some architectural endeavors, as well as this does a really good job of being practical. Mostly because it doesn't oil can as much either, because it's a rigid material, because it's bend. You can imagine if you fold up a piece of paper, you can't bend it as well as just like a flat piece of paper, which ripples quite a bit. You can perforate this stuff, do really high, cool design stuff with it, do all kinds of CNC things. I mean, you look it up and there's all kinds of examples of all the cool things you can do with the various profiles you can use with single skin. But even though we are talking about rain screens, IMPs can also be corrugated, believe it or not. So we're going to play another little quick comparison game, okay? One of these, again, is a built-up wall using single skin, corrugated this time. The other one is an exposed IMP system. Again, kind of associate these two. I'll give you guys 3 seconds to guess. Look it over. Ooh, left, right, left, right. Oh, there we go. Switched it up on you this time. So the IMP is actually on the right this time. And if you have a high resolution screen there, you'll see just a little bit of a gap there, little bit of a gap there, identifying it as an IMP. Otherwise, you wouldn't even be able to tell, right? This is a 3, 4 inch panel, 3 feet wide, something like that, directly onto studs, really high performing. The other thing you'll notice too, look at this corner. Those are exposed teeth. There's no trim on that corner for a corrugated panel. Look at this trim, right? What we can do is we can actually miter the inside of that insulated metal panel and then bend it 90 degrees in order to wrap a corner and have that insulation on insulation connection. Something that is pretty neat and can be done even with a corrugated panel. You just gotta ask. There we go. Something that's growing in my market quite a bit and might be growing in your guys' market as well, especially if you guys are doing a lot of university work. Thin brick. Ooh, thin brick is awesome. We're a big fan of it because it's a sixth the amount of brick, which means it's a sixth the amount of carbon. So we're big fans. But this is a really cool system that doesn't require a mason, which saves you a lot of money. It's fantastic. Essentially, what this is, it's a tracked system that you can attach onto a rain screen with an air gap in the back, just like you normally would. And then you can essentially take these bricks that are profiled so that you can put them in and then snap them into place. And then essentially, I mean, a cake maker could come through and pipette the mortar around them, and they look like brick, they act like brick, they are brick. It's just thinner and installs quicker. So really popular, like I said, growing in higher education. And to illustrate how well this stuff can look and perform, especially in conjunction with an IMP, we'll go through a few case studies of examples we've seen. First of which being good old-fashioned code building, fantastic building. You'd look at it and you'd be like, oh, that's a cool brick building. 95% of it is that rain screen IMP in there. So it's supporting this thin brick facade. I actually had the chance to see this building in person. There's a fountain in the middle of it, which is crazy. 2030 challenge project, LEED platinum building. Laughably, they did do ACM around the base, which was oil canning when I saw it, which I thought was very funny. But again, you'd look at it and you'd be like, oh, that's not IMPs. That's IMPs. That's how it goes. Something a little bit more familiar to our industry. These panels normally like to be on relatively big projects, and so distribution centers, plants, manufacturing, that kind of stuff is where this stuff normally likes to live, but we are getting more into higher design stuff, especially with this rain screen application. But this is an exposed IMP, just to kind of show more and more of what it can do. What we have here is Brampton, Ontario, so a bit thicker panels up in Canada. And we have this kind of white, kind of monolithic wall, right? A little bit imposing, unfortunately. And so what we can do is take advantage of the steel on steel with the insulation on the inside. Remember, I mentioned you can riddle that exterior face with holes and never run into any issues. What we have is some surface mounted fins on here, right? Running the length there so that we can give a little bit more movement to that facade. A really nice job of breaking that up while still being very economical. But on the vertical circulation, we go with something way more architectural. This kind of nice orangey terracotta look. We're doing more of a flat panel. Still in IMP, of course, but we're doing that angled corner with these adjusted legs so that we can line in between this curtain wall and this corner. Again, no trim here, no seams, anything like that. Just nice intentional grid lines. Still very good looking building, good application of that kind of technology there. Again, another distribution center, especially in Canada. We love our Canadian projects. Shout out Canada if you're in attendance. So this is Brampton Shoes Distribution Center up in Quebec. Another fun story with this one is I believe it was a corner lot condition. One's customer facing, one's employee facing. I'm sure you can discern which is which, but showing the heights that you can achieve with these IMPs, going up pretty tall, this nice, kind of industrial slate color. And then as you get to that curtain wall, you transition to this Rainscreen panel that we're talking about with that integrated rail there. And you can do the suspended, in this case, perforated single skin so that you can greet your customers with this very nice entry, this cool transition, very modern, very interesting take, and a good use of IMPs overall. Something again you'd look at and you'd be like, that's totally not IMPs. This is another IMP job. Again, acting as a rain screen there. Gilbert Place at Virginia Tech. Seeing much denser materials toward the bottom. We can swap our little rail out for full on brick ties if we want to do full width brick or thin brick, and then get more delicate as we go up. And so this is a really attractive for some projects where again we need to get in there quick. Construction time is time that we can spend being our customer can be spending making money. And so time is money in our industry. If we could get the building heated, interior started sooner, this is something that is very attractive to people, especially with a panel like INPs, where it's not worried about UV radiation actually deteriorating. It can be exposed indefinitely while you're waiting for your final facade pieces to show up. And this is an example of just that, where we've done a fantastic job of keeping this kind of thermal continuity of the exterior envelope, but then on the exterior, you can break up these massings with these variants in materials as you go up. So we have our trusty hokey stone, all kinds of stone, and then, as I mentioned, get more delicate with metals as we move up the way. So very good looking application there as well. Now, this is a fun one. This is the back half of that corrugated panel we saw in the guessing game there. As Canal Boathouse in New Haven, forget the state, Rhode Island, I believe. But we can curve these panels too. We can actually do segmented curves, which is what is illustrated here, or in cold storage applications, which we also do. We can do full-on column wraps up to a foot, right? Curve these panels truly as an actual C shape. So just know that going in that if a curve is necessary, IMPs can also still do that while maintaining that thermal continuity. The other thing that people see about this and are rather intuitive or thinking about the future is, again, speed of construction is really attractive. How do I cover even more square footage as quickly as possible? Well, if you're game, we're game kind of a deal. So this is the new Hilton Tower Convention Center in Columbus, Ohio. This is a situation where we had a prefab job, right? Where this is covering up a lot of square footage, especially at the vertical circulation. And we can attach our studs prior to it showing up to the job site, crane it up there, and then attach it via this. And then you get this nice segmented look with just crazy quick install speed. So another good application, a good example of how we can also do prefabrication if necessary. Now, the final thing I'll leave you guys off with is our final learning objective, which is kind of tips of the trades, different codes you're going to run into if you are pursuing something like this, or even other plastic installations. The good news is that you're spoiled in the IMP environment. No matter what manufacturer you go with, this is really good, cool technology. So with that being said, plastic insulations are going to be subject to a little thing called NFPA 285. And I encourage you guys to learn a little more of this. Maybe go watch another AIA about it specifically. But the shorthand version, it's a pass-fail 30-minute fire test for facade systems. It's kind of an industry standard. We live in this quite a bit. And the reason for that is because it measures things like smoke, temperature, fire spread of your entire building assembly, making sure that it can perform when it needs to perform in the event of an emergency. Just know again, we pass these things with standard materials, not a big deal. But FM approval is also expected too, especially if you're not pursuing a rain screen where you're not going to have a really complex assembly, something a little bit more like this. This is an example of our very nice fire performance with IMPs overall. FM approval, for those of us who don't know, the highest insurance standard you can get as far as building materials are concerned. And this is illustrated here. This was unfortunately an arson fire in Belgium back in 2014. And you can see here, fire was on there for a while, really chewing up and melting these panels on the exterior. But what we're not seeing is the inside, right? The inside's what's important because this exterior can look, ugly as long as it wants, as long as it's still performing. But we want to be able to make sure that we can still work on the inside. So what does the inside look like? Well, There you go, right? Still a bunch of happy German workers doing what happy German workers doing, which is working, having a good time, not necessarily worrying about have to tearing everything down or close up shop immediately because they can schedule out the reconstruction of this because the product is still performing. And that's what we're talking about with the importance of being redundant with these systems is because when we're working within redundancies, protecting ourselves from protection, it's great. And it can lead to examples exactly like this. Final thing we'll talk about is a little bit of cost. I won't talk about specific prices as far as like quoting and things like that. You'll have to reach out to us project specific to figure out what these are going to cost kind of per square foot. I will tell you it's very comparable as far as like more economical panels like that panel with the integrated hat channel, as well as some of our just more basic finishes and things like that. If you want something more architectural that is going to be, the trimless ends, the nice folded corners, you want it corrugated, you want custom colors, all that stuff that is going to get up in price a little bit, but again, very comparable when you talk about cost per square foot compared to a multi-component system that's going to have a similar aesthetic. But again, a big selling point here and the name of the game is speed of construction, and these things just go up so stinking quick. Again, 50% quicker on average. So you're making up a lot and labor cost, all that stuff, storing, staging time. So just know that going in as you receive these quotes, if you're not already blown away by the number, just know you're even going to save even more on the construction time. So, wrapping stuff up here, guys, just know that our website is also a good resource if you're looking for standard details. We have CADs, DWG, stuff like that. We also have Revit packages that you can request and download so that you can get your families and plug them in pretty early on. This QR code will take you to our carrier panel system, which is that integrated hat channel system. Just a nice little token I like to leave you guys with. The other thing with Kingspan is that we're big team players. We like doing these outreaches. We like doing these innovative companies and aligning ourselves with those like Acelabs. That's why we're here. We're here to be a resource for you guys. A large portion of those 22,000 employees are nerds like me with advanced degrees who are foaming at the mouth to help you guys with your complex problems because we want to make the world a little bit lower embodied carbon and higher performance. So I'm really passionate about it, but just know if you need things like stamps, drawings, anything like that, we can absolutely assist. Just let us know. My contact information will be at the end of the presentation if you want to take a snapshot of it, and I'm sure Ace Labs will also have it. Really quick, Kayla, we'll go through the conclusions and then we'll wrap everything up. We talked about how we designed an effective building envelope. We talked about multi-component systems, kind of beat down on them a little bit, compared that to single component systems, and then we wrapped everything up by looking at some pretty photos of IMPs and what they can do. So keeping that in mind, folks, thank you again for having me, Ace Labs. We will open it up to questions here in just a moment. My contact information is here. Let me know if you'd like to learn about IMPs or any of our other divisions. I'm happy to point you guys in the right direction. Thank you again. Appreciate it.
Awesome. Thank you so much, Dakota. Let's go ahead and jump into some questions. We probably won't
Mhm.
have time to get to all of them, but we'll go ahead and get started here. So this question was asked pretty early in the presentation, I think about like 5 minutes in. So
Okay.
they're asking if you have some more current numbers since 2020. You referenced some 2020.
Oh, as far as the USGBC studies, yeah, that is a slide that I sympathize with that person because I've been asking for some updated numbers myself. I assume that they've increased, but we should definitely look into that. Short answer, I don't have updated numbers, but just know this is a big issue. We're still one of the biggest contributors, and you can have a tangible effect on that by pursuing more companies with environmental product declarations, LCAs, who can prove that they actually are having a lessened environmental impact. So hopefully that answers your question.
Yeah, definitely. Thank you. All right. Next question is it's a little bit more of a statement and a question.
Sure, sure.
Um, it says R8 is wild and make me do a double take. I thought R 6.5 was about the limit for adjusting the cold weather performance. What
Mm.
product is R8 or are all of them R8?
Fantastic question. So the R8 is linked to our proprietary hybrid polyisocyanurate, PIR for short. That is quad core. That is the distinctly gray color that we talked about, the insulation. Kingspan's the only people who have that. And it's funny you bring up cold temperatures because, again, those of us who know in the insulation world, insulation's measured at two different temperatures. And so 70 degrees is what we're promoting with that because our buildings are 70 degrees. And so that's where you get the R8. But in colder climates, it actually jumps up to R9. So if you are doing a cold storage application, freezer, clean room, something like that, I don't know why you would keep a clean room that cold, but in that application, it is actually R9 per inch with that quad core product. So again, very good question. I forgot to touch on that.
No worries. And this is by the same person here, and I think this will
hmm
probably be the last question for now. Does Kingspan offer hydrothermal simulation to model thermal bridges on projects?
Ooh, that sounds like a very project specific question. That admittedly would be a little bit too technical for me, but as I mentioned, we have so many engineers on staff and stuff. I'm sure we could at least point you in the right direction, if not actually do that. I haven't unfortunately heard of that. I know we do a lot of performance modeling, things like that. We actually worked with Kieran Timberlake on a particular software. I believe it's like Trello or something like that that measures that kind of stuff. But just if you'd like follow up with me on that and I can dig deeper into that. I'm sorry I don't have a direct answer for you, but that's a great question.
That's all right. And we are right at time here, so we'll just be mindful of that and go ahead and wrap it up.
Excellent.
So if there's any remaining questions that we didn't have time to answer, don't worry, we'll be sharing all of those questions and your contact information with Dakota to follow up via email afterwards. So with that being said, Dakota, would you like to wrap us up with any final notes here?
Oh, go birds, I guess. No, I'm just kidding. Thank you so much for having me, guys. Seriously, it's such a pleasure. I look forward to hanging out with you guys in the future as well. So I'm actually, one thing I will say is I actually followed you guys before I even got invited to do this. I've been a big fan for a long time. So it's really weird how I'm kind of manifesting this stuff. So again, thank you so much.
Yeah, well, thank
Awesome.
you. Yes, it was a pleasure. That was a really great presentation, so thank you for that. And folks, if you filled out that poll, just keep an eye on your inbox here over the next couple of days. We'll be connecting you directly with the Kingspan team to get some additional questions answered and have a more in-depth conversation. So keep an eye on your inbox for that. And thank you, everyone. We hope you all enjoy the rest of your day.
Thank you, everyone.
Thanks, everybody.